Okay, students, start the probability. So in probability, there are two experiments. One is deterministic experiment. Second one is a random experiment. So in deterministic experiment definition, the experiment which will give same outcome every time under identical conditions when the experiment performed. This is the definition of deterministic experiment. The experiment which will give same outcome every time under identical conditions when the experiment performed. This is the definition of deterministic experiment. Second one, random experiment. An experiment which when repeated under identical conditions do not produce same outcome every time, but the outcome must be one of the several possible outcomes is called a random experiment. Friend, random experiment, an experiment which when repeated under identical conditions do not produce same outcome every time, but the outcome must be one of several possible outcomes is called a random experiment. Friends, suppose I am taking example, toss a coin. Friends, toss a coin. Friend, toss a coin. I don't know head appears or tail appears. Friends, toss a coin. Example, friends, example, toss a coin. Toss a coin. Either, I don't know, either head appears or tail appears. But out of these possibilities, definitely one appears is called a random experiment. This is the example of random experiment. When toss a coin, I don't know either head appears or tail appears. Out of these possibilities, definitely one appears is called a random experiment. Next, second example, rolling a die. Friends, rolling a die. Should either one appears or two appears or three appears or four appears or five appears or six appears. I don't know, sir. I don't know either one or two or three or four or five or six appears. Definitely, out of these six possibilities, definitely one appears is called a random experiment. These are the examples of random experiment. Okay, students, have understood? Students, experiments are two types. First one, deterministic experiment. Second one, random experiment. So, random experiment, an experiment which when repeated under identical conditions do not produce same outcome every time, but the outcome must be one of these several possible outcomes is called a random experiment. Students, completed? The experiment which will give same outcome every time అంటే మనకి ఎవ్రీ టైం సేమ్ అవుట్కమ్ అంటే మనకి దీంట్లో మ్యాథ్స్ లో పాసిబుల్ కాదు. మీకు ఫిజిక్స్ అంటే మీకు ఆల్రెడీ మీరు ప్రాక్టికల్ చేస్తారు ఫిజిక్స్ లో స్క్రూ గేజ్ అలాంటి వాటిలో ఎవ్రీ టైం మనకి సేమ్ రిజల్ట్ వస్తుంది. ఇది ల్యాబ్స్ లో మాత్రమే పాసిబుల్ అవుతుంది. అంటే మన ఫిజిక్స్ ల్యాబ్ లో మీరు ఏదైనా ఒక ఎక్స్పెరిమెంట్ అంటే స్క్రూ గేజ్ అనే ఎక్స్పెరిమెంట్ చేస్తే మనకి ఎవ్రీ టైం సేమ్ రిజల్ట్ వస్తుంది. అది ఎగ్జాంపుల్ ఏదో డిటర్మినిస్టిక్ ఎక్స్పెరిమెంట్. సో ర్యాండమ్ ఎక్స్పెరిమెంట్ మీరు ఆల్రెడీ 10th క్లాస్ లో చదివే ర్యాండమ్ ఎక్స్పెరిమెంట్. ఇప్పుడు సపోజ్ కాయిన్ టాస్ చేస్తాం అనుకో మనకి హెడ్ వస్తుందో తెలియదు, టైల్ వస్తుందో తెలియదు. కాకపోతే మనకి ఏదో ఒకటి వస్తుందో తెలుస్తుంది. కానీ డెఫినెట్ గా మనకి హెడ్ పడుతుందో తెలియదు, టైల్ పడుతుందో తెలియదు కదా. అదే ర్యాండమ్ ఎక్స్పెరిమెంట్ అంటే. ఒక డైకి ఎన్ని ఫేసెస్ ఉంటాయి? డైకి 6 ఫేసెస్ అంటే నెంబర్స్ అనేవి 1 2 3 4 5 6. అంటే ఒక డైని మీరు రోల్ చేస్తే కంపల్సరీ ఈ నెంబర్స్ ఏదో ఒకటి వస్తుంది. ఎగ్జాక్ట్ గా 1 ఆర్ 2 ఆర్ 3 ఆర్ 4 ఆర్ 5 ఆర్ 6 చెప్పలేం కదా. దాన్నే మనం ర్యాండమ్ ఎక్స్పెరిమెంట్ అంటాం. Next, students, sample space is equal to sample space is equal. Next definition, sample space. The set of all possible outcomes. The set of all possible outcomes. The set of all possible outcomes in a random experiment. In a random experiment is called a sample space. Friends, sample space is equal to the set of all possible outcomes in a random experiment is called a sample space. Friends, sample space is denoted by S. Suppose toss a coin, total possibilities is equal head or tail, H comma T. Suppose rolling a die, total outcomes is equal friends 1, 2, 3, 4, 5, 6. Friends, when a coin is tossed two times, when coin is tossed two times, what are the possibilities, friends? Coin is tossed two times, what are the possibilities? So coin is tossed two times, what are the possibilities? HT, TH, HH, TT. Friends, when a die is rolled twice, what are the possibilities? Total possibilities is equal to die is rolled two times. What are the possibilities? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6 up to last 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So when die is rolled two times, total possibilities is equal friends. Coin is tossed 1. In a coin is tossed, total possibilities is HT. So N of S is equal, number of elements in S is equal to 2. When die is rolled one time, friends, total possibilities N of S is equal, total elements in S is equal to 6. When a coin is tossed twice, so N of S is equal to 4. So die is rolled two times, total elements is equal, N of S is equal, friends, N of S is equal, die is rolled twice, N of S is equal to 6 square, 36. Friends, sample space, the set of all possible outcomes in a random experiment is called a sample space. Sample space is denoted by S. Suppose example, toss a coin, total possibilities is equal HT, and a die is rolled, possibilities is equal 1, 2, 3, 4, 5, 6. Coin is twice, HT, TH, HH, TT. Friends, when a coin is tossed thrice, how many possibilities? What are the possibilities? When a coin is thrice, when a coin is tossed thrice, what are the possibilities, friends? Friends, one coin is tossed thrice, HT. So here, HT. Here also possibilities HT. Here also possibilities HT. Here also possibilities HT. Friends, here also possible HT. Here also possible HT. So a coin is thrice. So here total possibilities is equal to H H H H H H. Next H H T H H T. Next friends H T H H T H. Next H T T. Next friends T H H. Next T H T. Next T T H. Next T T T. Friends, a coin is thrice. Total possible H H H H H T H T H H T T THH, THT, TTH, TTT. So total possibilities is a question. A coin is tossed thrice. Total possibilities. So N of x is equal to 2 cube. 8. Friends, a coin is tossed 4 times. Total possibilities is equal to a coin is tossed 4 times. 2 power 4, 16. 16 చెప్తారు స్టూడెంట్స్ 2 power 4 16 is equal total is equal 16 possibilities are students completed. అసలు నోట్స్ రాస్తున్నారా నోట్స్ a coin is tossed 4 times. A coin is tossed 4 times. H T H T here also H T 4 times friend here H T here also H T 4 times. So here also H T here H T here H T. So a coin is tossed 4 times. This is the tree method friends. First was H H H H. Next friends H H H T. Next friends H H so H H T H H H T H. Next one H H T T H H T T. Next friends next H T H H. Next H T H T H T H T. Next H T T H H T T H. Next H T T. From total 16 1 2 3 4 5 6 7 8 but here one time friends sorry here second friends so here H here also HT 1 second friend 4 times so HT here also HT here HT 4 times HT HT again here HT 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 here also HT 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 HT. So H H H T H H H. Next H H H T. Next H H T H H T H H H T H. Next H H T T H H T T. Next so H T H H H T H H H T H H. Next H T H T H T H T. Next H T T H H T T H. Next H T T T. Next here T H H T H H H. Next T H THHT. THHT. Next, THTH. THTH. Next, THTT. THTT. Next, TTHH. TTHH. Next, TTH. TTHT. TTHT. TTH. Next, TTTH. TTH. Last one, all are it is TTT. So total possibilities 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Friends, a coin is tossed 4 times, total possibilities is equal to 2 power 4, 16. These are the total possibilities, friends. Next. Friends, sample space is equal, friends, the set of all possible outcomes in a random experiment is called a sample space. Next, friends, next definition, event. Next definition, event. Next definition, event. Any subset of event. Any subset of sample space is called any subset of sample space is called an event. Any subset of sample space is called an event. Suppose example, friends, a coin is tossed twice, HH, HT, TT, next TH. Friends, A is equal to event of getting head twice. Friends, A is the event of getting head twice. So that is equal HH. So this is a subset of sample space. So HH is a subset of sample space. Again a subsection HT, TH. This is a subset of sample space. So any subset of sample space is called a event. Next, simple event. Simple event. So what is the definition of simple event? What is the definition of simple event? So simple event is equal an event A has an event E has one sample point. An event E has one sample point. One sample point is called simple event. So simple event. An event E has one sample point is called a simple event. Next, compound event. Compound event. An event E has more than one sample point is called compound event. Friends, an event E has one sample point is called a simple event. Friends, this is a simple event. This is compound event. So an event E has more than one sample point is called a compound event. This is simple event, only single element. So an event he has only one sample point. This is one sample point. This is called simple event. This is compound event. An event he has more than one sample point is called a compound event. Next, impossible event. Impossible event. Impossible event. Impossible event. An event never occur. An event never occur is called impossible event. Is called impossible event. It is denoted by 5. It is denoted by 5. Friends, impossible event. An event never occur is called impossible event. It is denoted by 5. For example, should a die is rolled, what are the possibilities, friends? What are the possibilities? A die is rolled. What are the possibilities? 1, 2, 3, 4, 5, 6. So an event of getting some more than 7. For example, an event of getting a number more than 7. So here maximum only 6. An event of getting number more than 7. So this is impossible. Example of impossible event. So an impossible event, an event never occur is called impossible event. It is denoted by 5. Friends, probability of impossible event is equal to, what is the probability of impossible event? Probability. Next. Okay, so next, sure event. Next, sure event or certain event. An event which always occur. An event which always occur is called sure event. An event which always occur is called sure event. Sure event or certain event. An event which always occur is called sure event. Okay, friends, next. So next, equally likely events. Next, equally likely events. So what is the definition of equally likely events, friends? Equally likely events. So probability of occurrence of probability of occurrence of probability of occurrence of every elementary event, every elementary event, elementary event remains same, remains same, is called equally likely events, is called equally likely events. So probability of occurrence of every elementary event remains same is called equally likely events. So as example, so toss a coin, probability of getting head is equal to probability of getting head is equal to so toss a coin, probability of getting head is equal to probability. So favorable outcomes by total possible outcomes. And a coin toss a coin. What are the possible HT? So probability is equal formula. Favorable outcomes by total possible outcomes. So favorable outcomes is 1, total possible outcomes 2. Probability of head is equal 1 by 2. Probability of tail is equal to also 1 by 2. So here these are equally likely events. Suppose a die is rolled. A die is rolled 1, 2, 3, 4, 5, 6. And probability of getting 1 point is equal. Probability of getting 1 is equal to students 1 by 6. Probability of getting 2, 1 by 6. Probability of 3 getting 1 by 6. Probability of 4 getting 1 by 6. Probability of 5 getting 1 by 6. Probability of 6 is equal 1 by 6. And these are equally likely events. Example of equally likely events. Question next. Mutually exclusive events. Next, mutually exclusive events. Friends, mutual exclusive events are disjoint events. So mutual exclusive events A and B are mutually exclusive if A intersection B is equal to 5. Friends, A intersection B is equal to 5, then A and B are mutually exclusive events. So A intersection B is equal to 5 means A and B has no common elements. Suppose example, when a die is rolled, S is equal to 1, 2, 3, 4, 5, 6. Friends, A is equal to event of getting odd number of points. A is equal to event of getting odd number of points. 1, 3, 5. Next, B is equal to event of getting even number of points. B be the event of getting even number of points. 2, 4, 6. So here A intersection B is equal to here A and B has no common elements. So A intersection B is equal to 5. So A intersection B is equal to 5, then A and B are mutually exclusive events or disjoint events. Next, exhaustive events. Friends, exhaustive events. Two or more events. So two or more events are said to be exhaustive events if A union B is equal to S. Friends, A union B is equal to S. Friends, A intersection B is equal to 5. A and B are mutually exclusive events. A union B is equal to S. A and B are exhaustive events. Example, friends, A is equal 1, 3, 5. B is equal to 4, 6. A union B is equal, friends. A union B is equal to 1, 2, 3, 4, 5, 6. That is equal to S. So this is the A union B. So exhaustive events, two or more events are said to be exhaustive events if A union B is equal to S. So A union B is equal to S, exhaustive events. A intersection B is equal to 5, mutually exclusive events. Next, classical definition of probability. Next one, classical definition of probability. N denotes number of elements present in sample space. So N denotes number of elements present in sample space. Next, M denotes number of elements favorable to occurrence of A. Number of elements favorable to the occurrence of A. First, N denotes number of elements present in sample space. M denotes number of elements favorable to occurrence of A. So probability of A is equal, P of A is equal to formula. Friends, number of elements favorable to the occurrence A, that is M, by number of elements present in sample space N. P of A is equal, probability of A is equal formula M by N. Friends, favorable to the event A by total possible outcomes. That is the probability formula. Friends, probability is equal formula favorable to the event A by total possible outcomes. So here M is equal to, M denotes number of elements favorable to occurrence of A by N denotes, N is equal to number of elements present in sample space. This is the probability formula. Probability P of A is equal to M by N. Friends, probability of occurrence, friends, occurrence of A is A, not occurrence of A is, friends, occurrence of A. Probability of occurrence of A is P of A. Probability of occurrence of A is P of A. Probability of non-occurrence of A is P of A bar. So probability of occurrence of A is P of A. Probability of non-occurrence of A is P of A bar. So P of A is equal to M by N. What is the formula of P of A bar, friends? What is the formula of P of A bar? P of A bar is equal to, P of A bar is equal to, P of A is equal to, friends, P of A is equal to, P of A is equal to, friends, P of A bar is equal to, here N denotes, friends, here N denotes number of elements present in sample space. And here reverse Lasson's constant. Okay, friends. So P of A is equal to M by N. Friends, P of A bar is equal, friends, P of A bar is equal to, friends, number of elements present in sample space N minus number of elements favorable to the A, N minus M by N. So this is P of A bar. Friends, total possible outcomes minus favorable outcomes by total possible outcomes. So P of A bar is equal to N minus M by N. So that is equal to, P of A bar is equal to N by N minus M by N. Here N get cancelled. P of A bar is equal to 1 minus M by N is equal to P of A. So here what is the formula? P of A plus P of A bar is equal to 1. So P of A plus P of A bar is equal to 1. So probability of occurrence of A is A. Probability of non-occurrence of A is P of A bar. Here what is the formula? Here P of A plus P of A bar is equal to 1. So here N denotes number of elements present in sample space. M denotes number of elements favorable to occurrence of A. Yeah, occurrence of A. This is M. Friends, M is always less than or equal to N. Next, M is always greater than 0. Friends, 0 less than or equal to M less than or equal to N. Friends, here N is number of elements. N is number of elements present in sample space. M is number of elements favorable to the occurrence of A. So M is always less than or equal to N. So M is always positive. Therefore, 0 less than or equal to M less than or equal to N. So dividing by N, 0 less than or equal to M by N less than or equal to 1. So 0 less than or equal to M by N is equal to M by N is equal to P of A. Probability of A less than or equal to 1. Friends, probability lies between 0 to 1. Range of probability is equal. Friends, P of A belongs to 0 to 1. Friends, range of probability, minimum value 0, maximum value 1. Friends, this is probability of impossible event is equal. Friends, probability of impossible event is equal to 0. Probability of phi is equal to 0. Probability of certain event or sure event is equal to probability 1. P of S is equal to 1. So the probability lies between 0 to 1. Minimum value is 0, maximum value is 1. Probability of impossible event 0. Probability of certain event or sure event is equal to probability 1. Right answer, right answer. So the range of probability, maximum value 1, minimum value 0. Probability of impossible event 0. Probability of certain event or sure event probability 1. Okay, next one. Friends, suppose probability of at least one of A and B occurs means calculate A union B. Friends, A union B, at least one of A and B occurs. So suppose probability of at least one of A and B occurs, calculate probability of A union B. Next, suppose probability of A and B occurs, calculate A intersection B. Friends, A intersection B means A and B. Occurrence of A and B. Friends, A union B means at least one of A and B occurs. Friends, suppose probability of at least one of A and B occurs means calculate probability of A union B. Probability of both A and B occurs, calculate probability of A intersection B. Probability of neither A nor B occurs means calculate probability of A bar intersection B bar. And A bar intersection B bar means neither A nor B occurs. Friends, suppose find the probability of at least one of A and B occurs, calculate probability of A union B. Probability of A and B occurs, calculate probability of A intersection B. Probability of neither A nor B occurs, calculate probability of A bar intersection B bar. Students, in Venn diagram, this is set A, this is set B. So this is A, this is B. So this part is A intersection B. So this part is A intersection B. Friend, this part is this is what is this part, friend? Only this part, only this part. Only this part is equal, friends. This is A minus B. Friends, A minus B or A intersection B bar. Friends, this is A minus B. From A you have to eliminate, you have to exclude A intersection B. Friends, A minus B means from A exclude A intersection B. Friends, this is A minus B or A intersection B bar. Friends, this part is friends, this part is equal to B minus A or B intersection A bar. Friends, this is B intersection A bar or B minus A. This is A minus B or A intersection B. Friends, probability of A minus B is equal formula, friends. Probability of A minus B is equal, friends. So the probability of A minus B is equal from A, we have to remove A intersection B, friends. P of A minus B is equal to from A, we have to remove A intersection B. So P of A minus B is equal formula P of A minus P of A intersection B. So you have understood or not? So this is A minus B. So P of A minus B is equal to, so P of A minus B is equal to from A. Friends, A minus B means from A we have to remove A intersection B. Friends, this part is removed. This is A. This total set is A. But A minus B, this is A minus B portion. This is A minus B portion. A minus B means from A we have to remove A intersection B. Therefore, P of A minus B is equal formula P of A minus P of A intersection B. Should I have understood or not? P of A minus B. Similarly, P of B minus A is equal to P of minus P of A intersection B. So, in 10th class, N of A union B is equal formula. N of A union B is equal N of A plus N of B minus N of A intersection B. P of A union B. This is addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. Friends, suppose this part is friends, A is equal, all of you required the word friends, A is equal to A minus B or A intersection B bar union A intersection B, friends. Friends, A is equal to this part is A intersection B bar union A intersection B. Taking probability on both sides, P of A is equal to P of A intersection B bar union A intersection B. Friend, P of A is equal to, here apply the formula P of A union B formula. So here apply the formula P of A union B. P of A union B is equal to P of A plus P of B minus P of A intersection B bar. P of A plus P of B minus P of A intersection B. P of A intersection B bar intersection A intersection B. So that is equal to P of A intersection B bar plus P of A intersection B minus. So this is A intersection B bar. So this portion is A intersection B bar. This portion is A intersection B. Friends, A intersection B bar and intersection A intersection B. So these two are have common elements, friends. No common elements. This is impossible event. Probability is 0. This value is 0. So this implies P of A intersection B bar is equal to P of A minus P of A intersection B. Okay, friends. This is the proof of P of A minus B. So P of A intersection B bar means P of A minus B. P of A minus B is equal to P of A minus P of A intersection B. So P of A is equal, so here these two are mutually exclusive events. These two are no common elements. So impossible event, probability is 0, minus 0. So P of A this implies P of A intersection B bar is equal to P of A intersection B bar is equal to P of A minus P of A intersection B. Therefore, P of A minus B is equal to formula P of A minus P of A intersection B. Next one is next odds in favor of an event. Next one, friends. Odds in favor of an event is equal formula. Number of elements favorable to the event A by, friends, odds in favor an event is equal formula. Friends, odds in favor of an event is equal formula. Number of elements favorable to the event A by number of elements not favorable to the event A. So the number of elements not favorable to the event A means this is, so numerator is equal, so P of, suppose that is equal to formula, that is equal to number of elements favorable to the event A is equal to N of A. Number of elements not favorable to the event A is N of A bar. So that is equal to friends, odds in favor of an event is equal formula number of elements favorable to the event A, that is equal N of A. Number of elements not favorable to the event A means N of A bar. So dividing by S, N of A by N of S by N of A bar by N of S. Friends, N of A by N of S is equal to P of A by N of A bar. Friends, number of elements favorable to the event A by total possible outcome. This is P of A. So this is P of A bar. Friends, number odds in favor an event is equal formula P of A by P of A bar. Next, odds against. Next formula, friends, odds against an event is equal to, so odds in favor an event is equal to number of elements favorable to the event A by number of elements not favorable to the event A. So odds against an event is equal to formula. Same oppositions, number of elements not favorable to the event A number of elements not favorable to the event A by number of elements favorable to the event A. Friends, odds against an event is equal formula number of elements not favorable to the event A by number of elements favorable to the event A. So that is equal formula. So that is equal n of A bar by n of A. N of A bar by n of A. First write down, friends. Odds in favor an event is equal formula number of elements favorable to the event A by number of elements not favorable to the event A. So that is equal n of A by n of A bar. So dividing by S, n of A by n of S, n of A bar by n of S. This is P of A, this is P of A bar. Next, odds against an event is equal formula number of elements not favorable to the event A by number of elements favorable to the event A. That is equal n of A bar by n of A. So dividing by S, dividing by n of S. So dividing by n of S, n of A bar by n of S by n of A by n of S. So that is equal to P of A bar by P of A. Friends, odds against an event formula P of A bar by P of A. Odds in favor an event is equal formula P of A by P of A bar. Okay, friends, this is the theory of probability. Probability weightage IP 1 7 marks to 4 marks. 1 7 to 4 marks. So probability weightage 1 7 marks to 4 marks. Means one problem. Probability one problem. Odds. Odds అంటే మనం ఆర్ట్స్ అంటే చూడాలి ఆర్ట్స్ అంటే some problems in probability. Problem, if A and B are, question number 1, if A and B are two mutually exclusive events, two mutually exclusive events, if A and B are two mutually exclusive events in a sample space S, in a sample space S, in a sample space S, such that P of B is equal to 2 into P of A, and A union B is equal to S. A union B is equal to S. Then P of A is equal to, So here A, B are mutually exclusive events. Probability of A intersection B is equal to 0. So here A union B is equal to S. taking probability on both sides, P of A union B is equal to P of S. So P of A union B is equal to P of A plus P of B minus P of A intersection B. So P of A, certain probability of certain events, certain event probability 1, P of A plus P of B. So here A and B are mutual exclusive. P of A intersection B also 0. So P of A plus P of B is equal to 1. So P of S, certain event probability 1. P of A plus P of B, here A and B are mutually exclusive events. So mutually exclusive events A intersection B is equal to 5. Probability of A intersection B is equal to probability of 5. Impossible and probability is 0. So this value is 0. P of A plus P of B is equal to 1. So P of A plus P of B is equal to 2 into P of A is equal to 1. So 3 into P of A is equal to 1. This implies P of A is equal to 1 by 3. Answer 1 by 3. Okay, next problem. Second problem, from the set of numbers 1, 2, 3, 4, 5, 6, 7, 8. Two numbers are selected random. Two numbers are selected at random. Two numbers are selected at random without replacement. Without replacement. Without replacement. The probability that their sum is more than 13. Their sum is more than 13. So from the set of numbers, total 8 numbers, two numbers are selected random with replacement, without replacement. So here the probability that their sum is more than 13. Friends, here favorable events is sum is more than 13. Friends, suppose I am taking that event is A. Friends, sum is more than 13. What are the favorable friends? What are the favorable outcomes? Sum is more than 13. Sum is more than 13 means 14, 15, etc. So here 9, 6, 7, 9, 6, 13. 7, 8, 8, 7, 8, 6, 6, 8. So number of elements in A is equal to 4. Friends, what is n of s here? This is favorable case. N of A is equal to 4. What is n of s? Total possible outcomes is equal. N of s is equal to. So here select two numbers at random without replacement. Friends, first select one number. First, suppose select 7. Total students 8. First select one number. Select one number 8, 7. Students, remaining numbers, total numbers remaining 7. Select second number, students. Total possibilities 7C1. Students, n of s is equal to 8C1 into 7C1. Students, first select 7. Total possibilities 8. Select one number 8C1 base. Next select second number. Students, without replacements, remaining total number 7. Select one number 7C1. So n of s is equal to 8c1 into 7c1. So P of A is equal to formula n of A by n of s. N of A is equal to 4 by 8c1 8, 7c1 7. So that is equal to 1 by 14. Answer 1 by 14. This is the favorable of the probability that the sum is more than 13. So favorable to the event is more, sum is more than 13, sum is 14 or 15. Sum 14, 8 6 6 8. Sum 15, 7 8 8 7. So n of A is equal favorable total positive, total favorable outcomes is 4. Next, total possible outcomes is equal n of s is equal, here select two numbers. Here without replacement, first select first number 7. First select one number. Out of 8 numbers, select one number, 8c1 ways. Remaining numbers, here already select one number, remaining numbers 7. Select second number, remaining 7 numbers. Out of 7 numbers, select one number, 7c1. This is n of s. So P of A is equal formula n of A by n of s. N of A is equal 4, n of s is equal 8 into 7, 1 by 14. Next problem. Student, question number 7. Four numbers are chosen at random. Four numbers are chosen at random from 1, 2, 3, 4, etc. 40. The probability that the probability that they are not consecutive. They are not consecutive. So try this problem. Four numbers are chosen at random from 1 to 3 out of 40 numbers. So here select four numbers. So for total possible outcomes, n of s is equal to total, here four numbers are chosen at random from 40 numbers. N of s is equal to 40 C4. This is n of s. But here calculate the probability that they are not consecutive. Four numbers are not consecutive. How to solve this problem, students? The probability that they are not consecutive is equal. Since P of A bar is equal formula, since P of A bar is equal formula 1 minus P of A. P of A bar is equal formula 1 minus P of A. Since P of probability of not consecutive is equal to P of A bar is equal 1 minus P of A. Probability of not consecutive is equal 1 minus probability of consecutive. So 1 minus. So probability of consecutive is equal favorable outcomes is equal select four numbers. What are the favorable outcomes, friends? Four numbers, select four numbers, that numbers are consecutive. Four numbers are consecutive. That total possible outcomes is equal, friends. Here n of s is equal to, friends, P of A is equal n of A by n of s. N of s is equal to 40 C4. N of A is equal to, friend, probability of consecutive. How many numbers? Select four numbers. That four numbers are consecutive. How many numbers, friends? How many numbers? Friend, first possibility. Select four numbers. 1, 2, 3, 4. Next possibility 2, 3, 4, 5. Next possibility 3, 4, 5, 6. Last number 37, 38, 39, 40. Suppose start with 38. Next number 39. Next 40. Next 41. But here last number 40. So here 1, 2, 3. Total possibilities. Total 1, 2, 3 up to 37 numbers. Total possibility is equal 37. 1 minus 37 by 40 C4. So one probability of not consecutive is equal to 1 minus probability of consecutive. 1 minus probability of probability formula n of a by n of s. N of s is equal to 40 C4. N of a is equal. What are the favorable outcomes? Here, 4 numbers are consecutive. First 1, 2, 3, 4. Next combination, next case 2, 3, 4, 5. Up to last number 37, 38, 39, 40. This is the last number. Total 1, 2, 3, 37. Favorable outcomes 37. So n of a is equal to 37. 1 minus 37 by 40 C4. Simplify this value, students. 1 minus this value 1 by 2470. So LCM 2470. 2470 minus 1. 2469 by 2470 answer. Okay, next problem. So yesterday we discussed problem combinations. Question number 13. S is equal to 1, 2, 3, last number 20. If 3 numbers are chosen at random, if 3 numbers are chosen at random, if 3 numbers are chosen at random from S, the probability for they are in AP. Friends, in previous question, G questions. Okay, friends, this is AP. Question next problem. One second. Should find the probability of getting. Should find the probability of getting. Find the probability of getting more than 7. Find the probability of getting more than 7. More than 7. When 2 dice are rolled. When 2 dice are rolled. Should find the probability of getting more than 7 when 2 dice are rolled. Friends, more than 7 means sum is 8, 9, 10, 11, 12. Friends, more than 7 is 8. So sum of 2 dice is 8, 9, 10, 11, 12. Friends, n of s is equal to 2 dice are rolled. Total possible outcomes is equal n of s is equal 6 square 36. Friends, sum is 8. Friends, 8 is equal. Friends, 8 is equal to, what are the possible distance? 8, 2, 6, 6, 2. Next, friends, 2, 6, 6, 2, 5, 3, 3, 5. Next, friends, next 4, 4. So that is equal, n of s is equal to 6 square 36. So 1, 2, 3, 4, 5. Parallel 5. Next, sum 9. So sum 9. 3, 6, 6, 3, 5, 4, 4, 5. Next, friends, here only favorable outcomes 4. Sum 10. 5, 5, 4, 6, 6, 4. Next, friends, 4, 5, 5, 4, 6, 6, 4. Next, total 3. 11, 5, 6, 6, 5, 2. 12, sum 12, 6, 6, 1. So P of A is equal to N of A by N of S. So N of A 5, 4, 9, 12, 14, 15 by N of S is equal to 36. So 15 by 36. So 3 5s, 3 12s. Answer 5 by 12. Answer 5 by 12. Okay, students, end of the class.